Spherical mirrors. Spherical mirrors are mirrors whose reflecting surface is a part of a sphere. Like if you see in this figure, this is a spherical mirror, and a mirror always has two surfaces. One is a reflecting surface and one is a polished surface. Now for this spherical mirror is a part of a sphere, and hence it's called a spherical mirror. Here we have another type of spherical mirror. We'll see the difference among them. But why is it called spherical? Because the reflecting surface is a part of a sphere. This reflecting surface is a part of a sphere, hence it is called a spherical mirror. Now every mirror has got two surfaces. In this mirror, the inner surface is reflecting. This inner one is reflecting, while the other is polished, and it is a non-reflecting surface. This mirror is called a concave mirror because you can see the reflecting part, this reflecting surface is like a cave. It's curved inwards. So hence it is called a concave mirror. But when you look up at this mirror here, the reflecting surface is bulging outwards, while the polished surface is inwards. This bulging out mirror is called a convex mirror. So a concave mirror is defined as a spherical mirror whose reflecting surface is curved inwards and faces towards the center of the mirror of the sphere. And convex is also a spherical mirror whose reflecting surface is curved outwards. It's called a convex mirror. Now for a concave mirror, the rays of light will fall on the side, on the reflecting surface. For a convex mirror, the rays of light will fall on the outer bulging surface. We'll now learn some terms related to spherical mirrors. First is the center of curvature. Every mirror is a part of a sphere. So the center of the sphere of which the reflecting surface of the mirror is a part of is called the center of curvature. Like in this case, here is the mirror, and this mirror is a part of a sphere. The center of this sphere, which in this case is denoted as C, is called the center of curvature of the mirror. This is the concave mirror. The same thing is for the convex mirror. Here we have the convex mirror. Now this convex mirror is a part of a sphere, and this sphere has a center. Every sphere has a center. The center of the sphere is called the center of curvature. So in a concave mirror, you can see that the center of curvature is in front of the mirror. But when it comes to convex mirror, the center of curvature is behind the mirror. Let me explain this point again. This is the mirror. The center of curvature is in front of it. And for convex, here is a mirror. The mirror is on the outer side. The center of curvature is behind it. Next is radius of curvature. Radius of curvature is a radius of the sphere of which the reflecting surface is a part of. We saw that this reflecting surface is a part of a sphere, and this radius of this sphere is called radius of curvature. Like this is called the radius of curvature, R. Is the radius of the sphere of which the mirror is a part of. Next is pole of the mirror. The center of the reflecting surface of a spherical mirror is called the pole. So we have the mirror, and this is the center of the mirror, which is called the pole. It is denoted as P. Here again we have the mirror, and the center of this mirror is called the pole. And now for the principal axis, which is very important. So we take the center of curvature and the pole and we join it. The line passing to the center of curvature and the pole is called the principal axis. See, here is the principal axis. Here too, the center of curvature and the pole. The line passing through the center of curvature and the pole is called the principal axis. So here are the different terms which we'll be using often in this lesson. In this slide we will learn another term called the focus of the mirror. Now for a concave mirror, here we have a concave mirror curved inwards, and rays that come parallel, all these rays are coming parallel to the mirror, parallel to the principal axis. After reflection, they all appear to come or converge at one point, and this is called the focus of the mirror. So this point here where they all converge is called the focus of the mirror. So focus of convex mirror is defined as rays that are parallel to the principal axis. After reflection meet at a point on the principal axis. This is called the focus of the concave mirror. Another thing, if you notice here, what is that mirror doing? It's converging all these rays. So concave mirror is also called a converging mirror. It's also called a converging mirror, and there are many applications because it is a converging mirror. Now here we have the convex mirror, which is bulging outwards. The reflecting surface is bulging outwards, and the rays that are parallel, here these rays are parallel. Parallel to what? Parallel to the principal axis. They all get reflected, and when they reflect, they diverge, they move away. But all of them appear to come from a single point, and the single point from where they come is called the principal focus. So focus of convex mirror, rays that are parallel to the principal axis after reflection appear to come from a point on the principal axis. This is called the focus of the convex mirror. And if you see the convex mirror, the rays are diverging. So the convex mirror is also called a diverging mirror. Here if you notice, see, all the rays are moving away from the mirror. In this case, the rays are moving towards the mirror. They're all moving here, concentrating in the small place. These are moving away. Another important point here is, in a concave mirror, the rays are actually meeting, and the focus is called the real focus. You can capture it on the screen. If you keep a paper there, you get a bright spot. But however, in the convex mirror, it is a virtual focus. It cannot be captured on the screen. If you keep a screen there behind the mirror, you do not get a bright spot. So this is one difference between concave and convex. In concave, the focus is real, the rays actually meet. In virtual, the focus is not real, it's virtual, the rays appear to meet. Concave is a converging mirror, and convex is a diverging mirror. We will define the pole of a mirror, the focal length of a mirror. So here we have the focus, and this is the pole. And the distance between the focus and the pole is called the focal length. So this distance here is called the focal length of the mirror. Same thing for convex. Here is the pole, here is the focus, and the distance between the pole and the focus, this distance here is called the focal length. So the distance between the pole and the focus of the mirror is called the focal length. Now there's an important relationship we must learn, is the focal length is always equal to radius of curvature divided by 2. We write this f equal to r by 2. So if the radius of curvature is 20 centimeter, the focal length will be 10 centimeter, half of it. So it's halfway. So if this is the focal, so here maybe the center of curvature would be here, and this would be equal to this. It is focus is halfway to the pole. So it's an important relationship that focal length is radius of curvature divided by 2, f equal to r by 2.